Alright guys, so today I'm going to be talking about how to run agarose gels for DNA electrophoresis. So, um, so basically, how the concept of how this works is that you have some DNA samples of various lengths, and you want to characterize this, or you want to separate them, what we call purify it. So how do you do it? We know that DNA are made from what? So ACTGs, and they are all negatively charged. So the longer it is, the more negative it will be. But at the same time, so we're making this aqueous gel. So you can imagine there are polymers. So when they are, they form this kind of gel, there is a gel pore. The smaller it is, because when you apply a current, the negative charge will try to go to the positive side. So they will flow to the positive side, which on your gel box will be marked as red, and then the negative side will be marked as black. And the smaller it is, the easier it is. It can go through these pores. So the faster they will travel. All right, so that's how this thing works, and then you get your separation. So basically, if this is like a gel, this is where you load the gel, and they flow in this direction. You have smaller pieces in the front and larger pieces at the end. All right, so how do you make your gel? So first you want to determine what percentage of a gel you want to make. Is it 1%? Is it 0.8%? So usually it's around like 1%, but it really depends on how good the separation it is. Let's say if you're trying to separate from 200 nucleotide long from 2000 nucleotide long, well, then you probably 1% or 0.8 is sufficient. But if you want to separate from 20, 20 nucleotide from 200 nucleotide, which both are very small, then I will probably go to somewhere around 3%. So what does 3% mean? It means in 100 milliliter of your TAE buffer, you want to add 3 grams. So how many percentage will be how many grams of agarose, which is the chemical that you're going to make the gel. So let's say, so what you want to do is you want to find uh, a flask and the or something like a container that can be microwaved. And the key is you want this to have a long neck. Why? Because this thing bubbles a lot when you microwave it. So if you if this too short, your sample will come out. So what you want to do is you want to first, so step one, measure agarose. How many percentage correspond to how many grams? And you want to put agarose inside flask. And third step, you want to measure out 100 milliliter of TAE, which is 1x buffer. And the fourth step is you want to pour this 100 milliliter into flask. So you add your 100 in there as well. And next, what you want to do is take this flask to a microwave. And what you want to do is you want to microwave for about 2 minutes. But you do not want to continuously microwave this for 2 minutes. You want to do it at 30 seconds first, and then you have to do it 5 seconds by 5 seconds. And between each 5 seconds, you want to open the microwave door just to check if it's bubbling out or not. And to what time you know it's good? Well, when you see it's completely clear solution, And then when you see, once you open the door, you are seeing bubbles forming on the top. Then you know it's hot enough. And then what you want to do is so pay attention, it's very hot now. And what you want to do is on this, take to your gel box. So your gel box usually will look something like this. And then, so there are, so this is the right side, the red side. So this is the positive charge, and this is the black side, this negative charge. And then there will be two electric cores, one on each side. And this will connect to your power. And inside this is, you want to pour your TAE buffer over, and your TAE buffer should have sufficient, but not too much. So what's good is that it should cover the top of your gel. And the next step, what you want to do after you heat this up is, so usually in this will be a gel holder. So a gel holder looks something like this. So it looks something like this, and then on the two end, it has a stopper. So you can use, when you put them on, you can use it to cast the gel. And then what you want to do is, once it becomes cooler, you want to pour this in here. But based on my experience, I'm gonna share some talk from experience now, how to make a better gel. So the first thing is you want to degas. So because there are a lot of bubbling, so right now in your agarose after the microwave, there are a lot of bubbles. And when you have bubbles, your lane becomes curvy and it won't become straight. So first thing you want to do is you can you can have different ways, but what I like to do is there this kind of this flask where you can connect to vacuum, and then you put the agarose in here, you connect it, you put a cap, and then you connect your vacuum. So in this way, the air bubble will go out that way. And instead of pouring the agarose into your gel cast box, gel holder, what I like to do is I like to pipette it into here using like a 25 milliliter pipette. So in this way, you don't have to introduce the air bubbles from pouring. So however you like to do it, I find this to be very efficient, especially when I'm doing a high agarose percentage gel. So after you pour this in into your gel box over here right now, so let's say you have your agarose in here already. And when should you pour it? You should pour it when it's still warm. How do you define warm? Once your hand can comfortably get a touch on it. But you don't want to cool down, because once you cool down, you cannot pour it into your gel box. It starts to gelate. The gelation process already started. And once you pour it in, you want to also put the link caster. So you have a link caster, which looks something like this, and this will go in there to make the loading socket. And you want to let this sit for 1 hour. I know this is usually some people say once you see the rest of the gel in the flask looks good enough, for like 20 minutes it should be good to go. But I want to emphasize that you should wait for 1 hour, because like in order to get a really good result, like you have to let it wait to let it gel completely. So 1 hour wait time. So after that, you want to take this. So you want to take out the stoppers carefully, and then do not take this this caster up yet. So right now you should have just the holder with the gel inside and the caster, but without the stopper. So you want to move this back into your gel box. And now you can just make sure the top of the gel is covered by TAE buffer. So you should look something like this. So now your gel, so your gel is in the middle, and then you got your TA buffer covering on the top of it. And you still have uh, your socket maker over here. So, and then, so I just also, you want to make sure um, that you're putting it in the right direction. So the socket where you load the sample should be on the black side, and then it will move to the part that is red. And after that, you want to carefully, very gently remove this. And what you will get is your gel with the sockets where you can load your sample. So depending on how big this is, you want to load sufficient amount. But depending on whether you are trying to purify or you just want to run analysis gel, it really depends on what you want to do, but just don't overfill. And then probably want to run a ladder, or you can purchase online to show you to compare. So ladder has already standardized length of DNA, so it tells you. So let's say this is 50, and then you can compare yours to this. So that, oh, my DNA is also 50 nucleotide base pair long, and usually recommend to run at 80 volts to 120 volts, but don't run it at a high temperature. Run at high temperature, it heats up the gel, and you will get a smear, which is like a faded line instead of a very clear line. And so basically is you want to avoid this heating problem. So what I like to do is I like to run my gel in 4C deli fridge. And how long you want to run this? So that means the higher the voltage, uh, you get to run faster. And depending on how long the gel box is, you really have to uh, like test run for a few trials before you decide. And then I like to run at 80 volts because it gives you a really clear separation between different DNA pieces, different sizes. So for me, I usually run this for 2 hours. And after 2 hours, what we want to do is, so I know people like to use ETBR, which is toxic, which is very toxic. And now there are already slightly more expensive but safer called uh, Cybergold staining. So what this does is, so what you're gonna do right now is you want to get a small box, and then in here you want to pour 50 milliliter of fresh TAE buffer and 5 microliter of your Cybergold. So this thing is safe, and it doesn't cause cancer. So you want to shake this well, and you want to take out your gel, and you put your gel inside here, and shake for 30 minutes. So it functions exactly as ETBR, but it's just safer. After staining for 30 minutes, you take out your gel, you watch it under a blue light box instead of, so another reason why it's safer is because you don't have to observe this under UV. Blue light will do, and then you can either cut your gel or take pictures, image it. So I hope this helps you when preparing your protocols. And I just want to emphasize on the importance of the degassing step, which many people will omit just for easier, but it really gives you a lot better result. And good luck with your experiment.